Hi, this is a real-time interview session. If you answer 70% of questions, you will be in a position to get hired in good organizations. All the best. This video will also questions with answers. Question 1. Can you explain the differences between Unix and Linux? Unix and Linux are both operating systems that share a common ancestry. Unix is an older and more established operating system, while Linux is a more recent development. Unix is generally considered to be more stable and reliable, while Linux is known for its flexibility, modularity, and customization. Linux is also more open and widely used, with many different distributions and variations available. Question 2. How do you manage users and groups in Linux, and what tools do you use? Users and groups can be managed in Linux using tools such as UserAdd, UserMod, GroupAdd, and GroupMod. These tools allow you to create, modify, and delete user accounts and groups, set user and group permissions and ownership, and manage password policies. In addition, Linux systems typically have graphical user interfaces and web-based interfaces that allow administrators to manage users and groups more easily. Question 3. Can you describe the Linux file system hierarchy and the purpose of each directory? The Linux file system hierarchy is a standardized directory structure that organizes files and directories on a Linux system. The root directory is the top-level directory in the hierarchy, and all other directories are subdirectories of the root directory. Some of the most important directories include /bin, /etc., /user, /var, and /home. Each directory has a specific purpose and contains files and directories related to that purpose, such as executable binaries, system configuration files, user home directories, and log files. Question 4. How do you manage Linux system updates and patches? Linux system updates and patches can be managed using tools such as yum, apt-get, or zyper, depending on the Linux distribution. These tools allow administrators to download and install updates and patches for the system and its components, such as the kernel, applications, and libraries. In addition, many Linux distributions have automated update mechanisms that can download and install updates automatically. Question 5. Can you explain the difference between hard links and soft links in Linux? Hard links and soft links are both ways of creating links between files in Linux. A hard link is a direct reference to the same inode as the original file, while a soft link is a file that points to the location of the original file. Hard links cannot be created across file systems, while soft links can. Soft links can also be used to create symbolic links to directories. Question 6. How do you secure a Linux server and what tools or techniques do you use? Securing a Linux server involves implementing best practices such as disabling unnecessary services, keeping software up to date, using strong passwords and access controls, enabling firewalls, and implementing intrusion detection and prevention mechanisms. Tools such as iptables, SE-Linux, and AppArmor can be used to implement these security measures and protect against attacks and vulnerabilities. Question 7. Can you describe the Linux boot process and the purpose of each stage? The Linux boot process involves several stages, including the BIOS, bootloader, kernel, and init system. The BIOS performs hardware checks and initializes the system. The bootloader loads the kernel into memory and sets up the initial RAM disk. The kernel initializes the system and loads the root file system, and the init system starts system services and applications. Each stage has a specific purpose in booting the system and preparing it for use. Question 8. How do you monitor and troubleshoot Linux system performance, and what tools do you use? Linux system performance can be monitored and troubleshooted using tools such as top, vmstat, iostat, sar, and stat. These tools allow administrators to monitor system resources such as CPU usage, memory usage, disk I/O, and network traffic, and identify potential bottlenecks or performance issues. In addition, Linux systems typically have logging and monitoring tools such as syslog, rsyslog, and logrotate, which can be used to track system events and troubleshoot issues. Advanced monitoring and logging systems such as Nagios, Zabbix, and Splunk can also be used to monitor and troubleshoot Linux systems. Question 9. Can you explain how Linux networking works and how you would troubleshoot network issues? Linux networking involves configuring network interfaces, routing tables, DNS servers, and network services such as DHCP, NFS, and Samba. Network issues can be troubleshooted using tools such as ifconfig, IP, netstat, traceroute, and ping. These tools allow administrators to diagnose connectivity issues, DNS resolution problems, and firewall issues. Advanced network monitoring and analysis tools such as Wireshark, Dump, and Top can also be used to identify and troubleshoot network issues. Question 10. How do you automate tasks in Linux, And what tools or scripting languages do you use? Tasks in Linux can be automated using shell scripts, cron jobs, and configuration management tools such as Ansible, Puppet, and Chef. Shell scripts can be used to automate repetitive tasks, such as system backups, log rotation, or software installations. Cron jobs can be used to schedule tasks to run at specific times or intervals. Configuration management tools can be used to automate system configuration and ensure consistency across multiple systems. Question 11. How do you configure and manage Linux firewall rules, and what tools or utilities do you use? Linux firewall rules can be configured and managed using tools such as iptables, Firewall, and UFO. These tools allow administrators to define firewall rules to restrict incoming and outgoing network traffic based on IP addresses, ports, and protocols. They also provide logging and monitoring capabilities to help identify potential security threats or attacks. Question 12. Can you describe the different types of Linux file systems, and when you would use each one? Linux supports various types of file systems, including x2, x3, x4, XFS, BTRFS, and NTFS. Each file system has different performance characteristics, features, and limitations. For example, x4 is a popular file system for general-purpose use, XFS is optimized for large-scale data storage and high-performance computing, and BTRFS supports advanced features such as snapshots and file system mirroring. Question 13. How do you manage Linux processes and services, and what tools do you use? Linux processes and services can be managed using tools such as systemd, init, and upstart. These tools allow administrators to start, stop, and restart processes and services, and configure system-level services and daemons. In addition, tools such as ps, top, and htop can be used to monitor and manage individual processes and their resource usage. 14. Can you explain how Linux permissions and access control work, and how you would manage them? Linux permissions and access control involve assigning ownership and permissions to files and directories, and using groups and users to control access to resources. Permissions can be set using tools such as chmod and chown, and access control lists, ACLs, can be used to provide more granular access control. In addition, tools such as sudo and su can be used to manage privilege escalation and provide access control to system resources. Question 15. How do you configure and manage Linux backups, and what tools or techniques do you use? Linux backups can be configured and managed using tools such as rsync, tar, and Amanda. These tools allow administrators to create and manage backups of files and directories, and schedule backups to run at specific times or intervals. In addition, techniques such as incremental backups and off-site backups can be used to ensure data resiliency and recoverability. Question 16. Can you describe how you would deploy applications on Linux servers, and what tools or technologies you would use? Applications can be deployed on Linux servers using a variety of tools and technologies, depending on the specific application and deployment requirements. Some common tools and technologies used for application deployment include Docker, Kubernetes, Ansible, and Jenkins. These tools can be used to automate the deployment process, manage dependencies and configuration, and ensure consistency across multiple servers or environments. In addition, scripting languages such as Bash and Python can be used to customize and automate the deployment process. Question 17. How do you manage Linux containers and orchestration systems, such as Docker and Kubernetes? Linux containers and orchestration systems can be managed using tools such as Docker, Kubernetes, and OpenShift. These tools allow administrators to create, deploy, and manage containerized applications and services, and ensure scalability, resilience, and reliability. They also provide advanced features such as automatic load balancing, auto-scaling, and rolling deployments. In addition, monitoring and logging tools such as Prometheus and Fluent can be used to monitor and troubleshoot containerized environments. Question 18. Can you explain how Linux virtualization works, and how you would use it in a production environment? Linux virtualization involves creating virtual instances of a physical server, allowing multiple operating systems to run on the same hardware. Virtualization can be used to reduce hardware costs, increase resource utilization, and provide isolation and security for different applications or services. Virtualization can be implemented using tools such as KVM, Xen, and VirtualBox, and can be used in production environments to provide scalable and flexible infrastructure. Question 19. How do you configure and manage Linux storage, including RAID and LVM? Linux storage can be configured and managed using tools such as fdisk, MKFS, and mount. RAID Redundant array of independent disks can be used to increase storage reliability and performance by combining multiple disks into a single logical volume. LVM, logical volume management, can be used to manage disk space and provide flexible storage allocation and resizing. Advanced storage technologies such as ZFS and Ceph can also be used to provide advanced features such as data compression, snapshotting, and distributed storage. Question 20. Can you describe the process of setting up and configuring a Linux web server, and what tools or technologies you would use? Setting up and configuring a Linux web server involves installing and configuring a web server software such as Apache or Nginx, configuring SSL certificates, and configuring virtual hosts and web applications. Tools such as Ansible, Chef, or Puppet can be used to automate the process and ensure consistency across multiple servers. Monitoring and logging tools such as Nagios, Zabbix, or ELK can be used to monitor and troubleshoot the web server and applications. Question 21. How do you ensure Linux system and application logs are properly configured, and how do you use them for troubleshooting and debugging? Linux system and application logs can be properly configured using tools such as syslogging or syslog, and log rotation can be configured to ensure that logs do not take up too much disk space. Logs can be used for troubleshooting and debugging by identifying and analyzing error messages, warnings, and informational messages. Advanced logging and monitoring tools such as Splunk, Graylog, or Loggly can be used to aggregate, analyze, and visualize log data from multiple sources. Question 22. Can you explain how Linux uses environment variables, and how you would manage them for system and application configuration? Linux uses environment variables to store information such as system paths, user preferences, and program settings. Environment variables can be managed using tools such as export, set, and unset, and can be used to configure system and application behavior. Advanced configuration management tools such as Ansible or Chef can also be used to manage environment variables across multiple systems or environments. Question 23. How do you manage Linux package repositories, and what tools or techniques do you use? Linux package repositories can be managed using tools such as Yum, apt-get, or Zyper, depending on the Linux distribution. These tools allow administrators to download and install packages and updates from centralized repositories, and configure repository settings and priorities. In addition, private package repositories can be used to manage custom or proprietary packages and dependencies, and package signing can be used to ensure package authenticity and integrity. Question 24. Can you describe the differences between systemd and CISVnet, and when you would use each one? Systemd and CISVnet are both init systems used in Linux distributions. CISVnet is an older and more traditional init system, while systemd is a more modern and advanced init system. Systemd provides faster boot times, improved service management, and better logging and troubleshooting capabilities. However, CISVnet is still widely used in many Linux distributions and may be preferred in certain situations or legacy environments. Question 25. How do you configure and manage Linux time synchronization, and what tools or techniques do you use? Linux time synchronization can be configured and managed using tools such as NTP, Network Time Protocol, CRNI, or Systemd Time Synced. These tools allow administrators to synchronize system time with network time servers, configure time zones and daylight saving time settings, and monitor time drift and accuracy. In addition, hardware clock synchronization and time drift correction can be used to ensure accurate and consistent timekeeping on Linux systems. That is it for this part 1. Next part will have advanced technical questions. I am doing an interview on Linux. Question 01. Can you explain the differences between a process and a thread in Linux, and how they are managed? A process is an instance of a running program, while a thread is a lightweight process that can run within a process. Processes have their own memory space, while threads share the memory space of the parent process. Threads can be used for parallel processing and can improve application performance. Processes and threads are managed using system calls such as fork, exec, and thread_create. Question 02. How do you configure and manage Linux network interfaces, and what tools do you use? Linux network interfaces can be configured and managed using tools such as ifconfig, IP, and Network Manager. These tools allow administrators to configure network settings such as IP address, netmask, gateway, and DNS servers. Advanced network configuration and management tools such as DHCP, VLANs, and bonding can also be used to provide network redundancy and load balancing. Question 03. Can you describe the different types of Linux shells, and when you would use each one? Linux shells include Bash, C Shell, Korn Shell, and Z shell. Bash is the default shell in most Linux distributions and is widely used for scripting and automation. C shell and Korn shell are also popular shells for interactive use and scripting. Z shell is a newer shell that includes advanced features such as tab completion and spelling correction. Question 04. How do you manage Linux system updates and patches on a large number of servers, and what tools or techniques do you use? Linux system updates and patches can be managed using tools such as yum, apt-get, or zyper. Configuration management tools such as Ansible, Chef, or Puppet can also be used to automate the update and patch process across multiple servers. Techniques such as rolling updates and testing in staging environments can be used to minimize downtime and ensure stability. Question 05. How do you configure and manage Linux system logs, and what tools do you use? Linux system logs can be configured and managed using tools such as syslogging or syslog. These tools allow administrators to define log sources and destinations, filter and classify log messages, and configure log rotation and retention policies. Advanced log analysis and monitoring tools such as Splunk, Graylog, or Logstash can be used to aggregate and analyze log data from multiple sources. Question 06. Can you explain the concept of Linux namespaces, and how they are used for containerization? Linux namespaces are a kernel feature that allows processes to have their own isolated view of system resources such as processes, network interfaces, and file systems. Namespaces are used in containerization to provide process and resource isolation for containerized applications, and to prevent conflicts and interference between containers. Docker and Kubernetes are popular containerization platforms that use Linux namespaces to provide containerization. Question 07. How do you troubleshoot and resolve Linux kernel panics and crashes? Linux kernel panics and crashes can be caused by hardware failures, driver issues, or software bugs. Troubleshooting and resolving kernel panics and crashes involves analyzing the kernel panic message, reviewing system logs, and checking hardware components such as memory, disks, and network cards. Kernel crash dump analysis tools such as kdump and crash can also be used to diagnose kernel crashes. Question 08. How do you manage Linux process scheduling and prioritization, and what tools do you use? Linux process scheduling and prioritization can be managed using tools such as nice, renice, and chrt. These tools allow administrators to adjust process priority levels, CPU affinity, and scheduling policies. Advanced process scheduling and monitoring tools such as groups and systemd can also be used to manage process resource usage and allocation. Question 09. Can you describe the differences between a hard link and a symbolic link in Linux, and when you would use each one? A hard link is a reference to a file that points to the same inode as the original file, while a symbolic link is a special file that points to the target file by name. Hard links can only be created within the same file system, while symbolic links can point to files on different file systems. Hard links can be used to create multiple references to the same file and save disk space, while symbolic links can be used to create shortcuts and aliases to files or directories. Question 10. Can you explain the differences between TCP and UDP in Linux networking, and when you would use each one? TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, are two of the most commonly used transport protocols in Linux networking. TCP provides reliable, connection-oriented data transfer, while UDP provides faster, connectionless data transfer. TCP is used for applications that require data reliability and error correction, such as HTTP, SMTP, and SSH. UDP is used for applications that require low latency and fast data transfer, such as DNS, VoIP, and video streaming. Question 11. How do you configure and manage Linux disk quotas, and what tools do you use? Linux disk quotas can be configured and managed using tools such as Quota, edquota, and reapquota. These tools allow administrators to define disk usage limits for users and groups, monitor disk usage, and enforce quotas. Quotas can be applied to specific directories or file systems, and can be used to prevent disk space exhaustion and improve system performance. Question 12. Can you describe the differences between a binary and source package in Linux, and when you would use each one? A binary package is a precompiled package that contains executable files and libraries, while a source package contains the source code and build scripts for a software package. Binary packages are easier to install and use, and are typically available in software repositories. Source packages are used for custom builds and advanced configurations, and can be used to customize software behavior or add new features. Question 13. How do you configure and manage Linux swap space, and what tools do you use? Linux swap space can be configured and managed using tools such as swap on, swap off, and fstab. These tools allow administrators to define swap partitions or files, monitor swap usage, and adjust swap settings. Advanced swap management tools such as Zroom and Swap can also be used to improve swap performance and reduce disk I/O. Question 14. How do you manage Linux system resource limits and quotas, and what tools do you use? Linux system resource limits and quotas can be managed using tools such as ulimit, settlemit, and groups. These tools allow administrators to define limits on system resources such as CPU usage, memory usage, and network bandwidth. Resource limits and quotas can be used to prevent system overload, ensure fair resource allocation, and improve system stability. Question 15. Can you explain how Linux process signals work, and how they are used for process management and control? Linux process signals are software interrupts that are used to communicate between processes or between a process and the kernel. Signals can be used for process management and control, such as terminating or suspending a process, or for handling errors and exceptions. Common signals include sigterm, sigil, and sigint. Signal handling can be customized using signal handlers and signal masks. Question 16. How do you configure and manage Linux kernel modules, and what tools do you use? Linux kernel modules can be configured and managed using tools such as modprobe, ulsmod, and rmod. These tools allow administrators to load or unload kernel modules, list loaded modules, and check module dependencies. Advanced module management techniques such as hot plugging and automatic module loading can also be used to improve system flexibility and scalability. Question 17. Can you describe the differences between a hard disk drive, HDD, and a solid-state drive, SSD, and when you would use each one on a Linux server? A hard disk drive, HDD, is a magnetic storage device that uses spinning disks to read and write data, while a solid-state drive, SSD, is a non-volatile storage device that uses flash memory to store data. HDDs are slower and less reliable than SSDs, but have higher storage capacity and are less expensive. SSDs are faster, more durable, and consume less power than HDDs, but have lower storage capacity and are more expensive. HDDs are commonly used for archival storage and data backup, while SSDs are used for high-performance computing and applications that require fast access to data. Question 18. How do you configure and manage Linux system time synchronization with external time sources, and what tools or techniques do you use? Linux system time synchronization can be configured and managed using tools such as NTP, Network Time Protocol, CRNI, or Systemd Time Synced. These tools allow administrators to synchronize system time with network time servers, configure time zones and daylight saving time settings, and monitor time drift and accuracy. In addition, hardware clock synchronization and time drift correction can be used to ensure accurate and consistent timekeeping on Linux systems. Question 19. Can you explain how Linux uses shared libraries, and how you would manage them for system and application configuration? Linux uses shared libraries to provide reusable code and data that can be shared by multiple applications and processes. Shared libraries are loaded into memory at runtime and can be updated independently of the application code. Shared libraries are managed using tools such as ldconfig and LDD. These tools allow administrators to configure library search paths, check library dependencies, and update library caches. Advanced library management techniques such as versioning and symbol renaming can also be used to ensure library compatibility and prevent conflicts between different versions of shared libraries. Question 20. Can you explain how Linux file permissions work, and how you would manage them for system and application configuration? Linux file permissions use a combination of read, write, and execute permissions for the owner, group, and others. File permissions can be managed using tools such as chmod, chown, and chgrp. These tools allow administrators to set file ownership and group membership, define file permissions, and manage access control lists, ACLs. Advanced file permission management techniques such as UMISC and StickyBit can also be used to improve security and control access to files and directories. Question 21. How do you configure and manage Linux firewall rules, and what tools do you use? Linux firewall rules can be configured and managed using tools such as iptables, firewalled, or UFO. These tools allow administrators to define firewall rules for incoming and outgoing network traffic, configure network zones and services, and monitor firewall logs and events. Advanced firewall management techniques such as application layer filtering and IPS, intrusion prevention system, can also be used to enhance network security and prevent attacks. Question 22. How do you manage Linux system resources such as CPU, memory, and disk usage, and what tools do you use? Linux system resources such as CPU, memory, and disk usage can be managed using tools such as top, free, df, and iostat. These tools allow administrators to monitor system resource usage, identify resource bottlenecks and performance issues, and optimize resource allocation and utilization. Advanced resource management techniques such as process affinity and CPU pinning can also be used to improve system performance and stability. Question 23. Can you describe the differences between systemd and CISVnet, and when you would use each one? Systemd and CISVnet are both init systems used in Linux distributions. CISVnet is an older and more traditional init system, while systemd is a more modern and advanced init system. Systemd provides faster boot times, improved service management, and better logging and troubleshooting capabilities. However, CISVnet is still widely used in many Linux distributions and may be preferred in certain situations or legacy environments. Question 24. How do you configure and manage Linux time synchronization, and what tools or techniques do you use? Linux time synchronization can be configured and managed using tools such as NTP, Network Time Protocol, CRNI, or Systemd Time Synced. These tools allow administrators to synchronize system time with network time servers, configure time zones and daylight saving time settings, and monitor time drift and accuracy. In addition, hardware clock synchronization and time drift correction can be used to ensure accurate and consistent timekeeping on Linux systems. Question 25. Can you explain how Linux package management works, and how you would manage software packages for system and application configuration? Linux package management uses software repositories to distribute and install software packages, and allows administrators to manage dependencies, updates, and configurations. Package management tools such as yum, apt-get, or Zyper can be used to download and install packages from repositories, check package dependencies and conflicts, and manage package updates and patches. Advanced package management techniques such as package signing and version pinning can also be used to ensure package authenticity and prevent package tampering. Question 26. How do you troubleshoot Linux network connectivity issues, and what tools or techniques do you use? Linux network connectivity issues can be caused by various factors such as misconfigured network interfaces, firewall rules, or DNS settings. Troubleshooting network connectivity issues involves analyzing system logs, checking network configurations and settings, and using network diagnostic tools such as ping, traceroute, and dump. Advanced network troubleshooting techniques such as packet capture and analysis can also be used to identify network bottlenecks and performance issues. Question 27. Can you explain how Linux virtualization works, and how you would use it for system and application configuration? Linux virtualization allows multiple virtual machines or containers to run on a single physical host, and provides isolated environments for running applications and services. Linux virtualization can be implemented using tools such as KVM, kernel-based virtual machine, VirtualBox, or Docker. Virtualization can be used for system and application configuration by providing flexible and scalable environments for development, testing, and deployment. Virtualization can also be used for resource consolidation and optimization, and to improve system security and isolation. Question 28. How do you configure and manage Linux system backups, and what tools or techniques do you use? Linux system backups can be configured and managed using tools such as tar, rsync, or Bacula. These tools allow administrators to create full or incremental backups of system files and directories, schedule backups, and restore backups in case of data loss or system failure. Advanced backup techniques such as deduplication and compression can also be used to reduce backup storage requirements and improve backup performance. Question 29. Can you explain how Linux uses process scheduling algorithms, and how they are used for process management and control? Linux process scheduling algorithms determine how system resources such as CPU time and memory are allocated to running processes. Scheduling algorithms can be preemptive or non-preemptive, and can be based on factors such as process priority, CPU utilization, and I/O wait time. Scheduling algorithms can be customized using tools such as nice, renice, and chrt, and can be used to manage process resource usage, prioritize critical processes, and prevent resource starvation.